on the topic of towards a sustainable biomass sustainability framework. Today talking about feedstocks and products. We still have a lot of people coming in, so you hear a lot of beeping, which we can't switch off. But being conscious of time, we will start, and you just get used to the beeping. First of all, we would like to ask everyone to mute yourselves, so we can have an undisruptive time at the webinar and the presentations. Just checking. Okay, so I'm Miriam Roda from the Supergen Bioenergy Hub at Aston University. I'm here today to chair the webinar, and I'm supported by a group of colleagues. First of all, I want to point to Freya and Katrina from the Supergen Central team, who will be our masterminds in the background to help us to coordinate the webinar and the smooth running. I also want to introduce Patricia Thornley, the director of the Supergen Bioenergy Hub, who will support the Q&A session later. And obviously, very important, we have an excellent lineup of speakers for today. So we have Dan Taylor from Aston University, we have Rebecca from the UK Centre for Ecology and Hydrology, we have Andrew from the University of Manchester, and we have Paramala from the University of Nottingham, who will give us insights into their research. A bit of housekeeping. The webinar is being recorded, and we will make the slides available later. And we will share the recording, but we will not share the Q&A session. Only the presenters will use microphones. So when we come to the Q&A session, we would like to ask people to put their questions in the Q&A bit of the Teams meeting. So there's on top a little icon saying Q&A. You can start putting in your questions there while we go along. To make it easier for us and to know who the question is addressed to, it would help if you say question for this person or this person, so we can address them more easily during the session. Just to flag, we will not be answering questions on policy options or questions regarding the sustainability framework consultation document. We will only answer questions related to our own science and the science we present here today. Okay, so I would say that's for the start. A bit of housekeeping. I will remind throughout the webinar a few things I've just said, because that's quite a lot of information. But I would say without further ado, and while people still coming in, we will kick out with the presentations now. So as I said, today's webinar is about towards a biomass sustainability framework, focusing on feedstocks and products. And next slide, please, Freya. So the purpose of the webinar is to make research around biomass sustainability widely available to support stakeholders in their response to the UK government's Common Biomass Sustainability Framework consultation. The Supergen Bioenergy Impact Hub is running 2 webinars, one today focusing on feedstocks and products, and we will run another webinar next Tuesday on the 27th of January, which is focusing on trees, crops, and carbon. The purpose really is to explore some of the questions around biomass as a sustainable feedstock for energy and products, and highlight the role of biomass in carbon regulations and practices of growing and trading biomass. Next slide, please. So, as I already introduced the speakers, we have Dan, Rebecca, Andrew, and Paramala talking about their research in a moment. Next slide, please. Just to give a really, really short overview of the biomass sustainability framework or the intents of the government. So what does the government understand about sustainable biomass? Only sustainable biomass can be considered to be low carbon. The UK only supports biomass that meets sustainability criteria across the economy in power, heat, and transport. And sustainability criteria cover the greenhouse gas emissions of the supply chain and environmental protection, especially land criteria. So there's a strong focus of the framework on land criteria and greenhouse gas emission. Next slide, please. The consultation document is divided into different topics or themes. As I just said, falling under the land criteria and the greenhouse gas criteria. There's also a section on MRV and around feedstock categories and definitions. Next slide, please. Okay, the purpose and aim of the Common Biomass Sustainability Framework is to be delivered as a policy document and used for bioenergy that is subject to a government support mechanism in the UK. And it also might be used as guidance by the unsubstituted market. And it's going to be reviewed regularly and updated. Updates will be published about every 5 years. That is what is suggested in the framework in the consultancy document. Next slide, please. So the overarching principles for developing sustainability criteria are around maximizing carbon benefits, minimizing wider environmental harm, align with wider government objectives, and align with criteria used in other countries around deliverability of sustainability and around the cost to the government, businesses, and consumers. So this just as kind of like a general overview. If people want to know more about the document, DESNIS has been running webinars and has provided information online on their websites where more information can be found. And as I said at the start, today's webinar is not about discussing the consultation document or the intents of the government, but we'll focus on our research we're going to present now. So I think the next slides are actually focusing about the research. So yeah, so the following presentations will focus around the sustainability research of the Supergen Bioenergy Hub, giving you a few insights on different areas where we have conducted work. Okay, Freya, to the next slide, please. Okay, thank you. So here just a quick insight on work we have done in the past around carbon stocks and carbon dynamics, showing that dynamics and time matters and really depends on plants and trees, grown management practices, the business models around how biomass is grown, and the regional context. What we have done with our research with a really strong focus is considering cumulative emissions over long time frames and accounting for example, forest carbon on a landscape level, not just on a stand level. Why is that important? Because management practices and business models often needed for long-term carbon stocks need to be considered in these accountings. Because, for example, if we focus on long-term carbon stocks and say forests should be grown for a long time, there might be points in forest growth where it comes to loss of CO2 and where integrated bioenergy can prevent these losses and maintain long-term carbon stocks. To the next slide, please. We have also done a lot of work around system boundaries and cross-sectoral approaches. With the findings that extended system boundaries, especially approaches around consequential LCA and multi-sector modeling, help to capture critical feedbacks and trade-offs in the system and capture interactions between different sectors and systems. So there's a strong narrative around widening system boundaries and to capture impacts and avoid unintended consequences, while narrow boundaries might limit the quantification of true GHG impacts and carbon removal potential as well. Next slide, please. We have also done a whole host of work around GHG accounting and performance, looking at GHG thresholds. Obviously, GHG performance can vary wildly depending on feedstock, technology, region, and management practices. So a single cross-sectoral threshold would ignore these differences and create maybe incentives going the wrong way. So flexible context-driven thresholds often better reflect actual sustainability and GHG trade-offs. As I said, we have done various work on that. And Freya, if I can ask you to go to the next slide. So I just wanted to point out some of the areas where we have done work in. We have published a whole host of work around these. The QR codes to the different research are available on this slide, which we will share later, where people can access more information and detail on that. And obviously, we're very happy to answer questions around that. And I pass the floor to Dan.
Thank you, Miriam. And I thought I had too many QR codes on my slide. So beyond the environmental analysis of sustainability of biomass in the UK, there are also the social aspects, and that's what this research really focuses on. And particularly as the social aspects of sustainability are often determinants for how successful the sustainable replacement of fossil fuels with biomass will be in the UK. So aligned to some of the questions in the consultation around social aspects, this research has shown that it's actually particularly important to mobilise public support for projects, as well as the obviously technical challenge of doing the bioenergy product itself. And this means that we need to think about, within the framework, trying to incentivise building things like social legitimacy around harvesting activities, and that's particularly for consultation questions 41 and 42. And this is really about how we realise sustainability within the context of our industry, our policy, and our society, so that we can actually bring people with us as a result of sustainability activities through biomass in the UK. And a cross-sectoral framework would hopefully contribute towards overcoming some of the identified siloed policy and siloed bio-based sectors that exist in the UK at the moment. And there's a couple of pieces of work there that will help you to find the references for that evidence. Onto the next slide, please, Freya. And then particularly more recently, through a political economy analysis, I've looked at what alternative policy frameworks could do to actually address social aspects of UK bioenergy. And what this has shown is that historical policy mixes have actually been hindered by complex trade-offs and silos. And I think that Andrew is going to be talking about how sustainability is quite a lot to do with different trade-offs and decision-making later on. And so actually we need to think about how we reward multi-dimensional benefits through policy mixes and incentives and policy incentives. And there's also the question of the review period for when this framework or when policy will be reviewed based on the latest scientific evidence. And from my research, I think that would be a really beneficial thing to be doing. I think the suggested period is 5 years, but there's clear evidence to suggest that a review period would help us achieve greater social sustainability through biomass if we're aligned to the latest evidence. Next slide, please, Freya. And I'm not going to talk about this a great deal because Andrew's going to talk in depth about the Supergen Bioeconomy Sustainability Indicator model, which is an incredibly useful model. And that's what I'm going to say on that. Otherwise, I'm going to spoil what he has to say next. And that is my last slide, Freya. Thank you very much.
Okay, thank you very much, Dan. And I'm now handing over to Rebecca to present some of her research.
Can you all see my screen okay? Am I sharing?
Yes,
Perfect.
it's all good.
So I'm going to run over land and grown biomass as my given title. So I thought I'd start by just talking over, because I'm talking about growing biomass, so I'm excluding waste, just to be clear. And I thought I'd run over what we have in the UK. So I primarily focus on the UK because that's where my research expertise is. So we're looking at those food crops. So for that, that's wheat, sugar beet, maize, and straw. We've then got as a co-product, we've got our dedicated crops, so our short rotation coppice, miscanthus, short rotation forestry, and our forestry co-products. And then, as I said, I'm not going to cover imports, not my area of expertise. When we talk about grown crops for imports, opposed to waste, which you also import, that's predominantly co-products from forestry operations, and then our biofuels as well. Just to give you an indication of what we're looking at in the UK in terms of numbers, this is the latest. I think there are probably more than this, so I go digging, but the latest I could find for 2023, update in 2025 in terms of area. We've got around, so this is area of crops growing for bioenergy. So looking at around 45,000 hectares of wheat, 3 of sugar beet, 73,000 hectares of maize. That's one of our biggest, and then a smaller amount of our short rotation coppice and miscanthus. And actually, there isn't any sort of, well, there probably is now, but very little commercial scale short rotation forestry. Co-products aren't listed in here because they're under different systems, so they won't get pulled up as an area. So I just ran through, obviously, they go to a mix of end uses. So at the moment, this is why the consultation is talking about bringing a framework. We have different biomass crops going to different end uses, which means they're under different frameworks. So there is an argument there for bringing those frameworks together, which is what the consultation is considering. There's one thing to also note with the numbers here about the potential difference between the food crops and the bioenergy crops, so the dedicated crops. The food crops numbers are based on that area you get is the area crop that we know is going to that use. So when it says 73,000 hectares of maize in the UK growing for predominantly biomethane or for energy, that is 73,000 hectares of maize for that end use. There is more maize in the UK, but it's 73,000 hectares that are going for bioenergy for that. For the short rotation coppice, the willow and the miscanthus, those crops, the numbers you get in this system is the numbers of planted crop. The amount of that that's actually going for energy use is quite variable. So at the moment, when this was done, it was around about 1% of the SLC was going into UK power stations to get tracked in, and about 40% of the miscanthus could get tracked in. So that's based on the expected yield of those crops. The rest of it may be going to domestic use, or it could be going to alternative feedstock. So both the SLC and the miscanthus have multiple end uses, so they can also be grown for animal bedding, for biomaterials, for packing, for the wood chips might be used for even decorative purposes. The difference between these crops and the energy crop, the food crops, is you're planting a crop that's in the ground for 25 years for SLC and miscanthus, so it can switch usage. So it could be planted for non-energy use, but then one of the harvests in its 25 years could go to an energy use. So it's slightly different in the way it's going to sit with any framework. And I think it's important to note that they are multiple use, but it's a single crop. So a single planted crop in a single location could have multiple end uses for our dedicated crops because they're longer lived. So I'm going to talk about, or roughly cover, because we're everything, how the current land use that we have for our bioenergy crops aligns with the proposed sustainable forestry framework, and some of the available evidence on sustainability of these biomass crops focusing on soil carbon. So this sits within the land section of that criteria. I haven't been quite as good as Miriam and not put every single question that is related to, or Dan have done, haven't been that organised. So I'm talking about land for dedicated crops. So this is our Cercia, miscanthus and our SRF. As there aren't much of them in the country at the moment, what we're really looking at is what the criteria are for where people want to plant them or what they're considering where they're planting. So I'm drawing on a workshop that I conducted quite a few years ago now with Supergen, but and also conversations I've had since then in various bits of research I've been doing with the industry. So we brought together industry, government, academia, some of the NGOs, some of the research councils, and also our Supergen colleagues to talk about what is it that people consider when they're putting crops into the ground, and what is their argument and discussion that they sit around that, so their thought processes. So generally what we found is there's a strong preference for using marginal agricultural land. People's definition of marginal agricultural land varies, and then we have some research on that as well that I'll put a link into later. What you need to look at here, in the graph, is we gave people the options. This was online. So people could comment on anything, and I did record the number of comments on who they were coming from, but we also then asked people within that workshop to vote on what they thought were the most important criteria for selecting where the crop should go. Those are the ones with the stars on. So that's our, in this side, so our net profit, the profitability of the crop, and then a lot around ecosystem services, biodiversity, and soil carbon net C. So those were the things. And so that strong preference from marginal land, what comes in part of that is the profitability. The crops can't generally compete with high valuable food crops. Therefore, they're pushing land or selecting land that has a low food requirement, which kind of fits in. We also then have land with high biodiversity or high soil carbon are considered undesirable for all stakeholders for different reasons. The industry's view on that is generally they're trying to avoid they want to get credit for any carbon sequestration in the future. So they want to target those lower carbon soils. They're also sensitive to social backlash for using land that's considered to be high value. Obviously, for policy and academia, they have slightly different viewpoints on that. These principles that are placed in the proposed framework kind of align with this. So there's a general alignment. There's also, as Dan was mentioning, quite a strong desire to widen the scope beyond greenhouse gas emissions and biodiversity to some of the social aspects. So this came up in the workshop of wanting to consider things like community value, other use of the land, job creation, as well as that greenhouse gas, which kind of fits in with what Dan was saying in his slides. The other thing we talk about, so I am going to put some caveats in this, not entirely drawing from my own work. So one of the caveats that I would say around that we might need to think about evidence we want to draw in is around protected land. So protected land is listed in the consultation. Here, the definition will be crucial. Now, this isn't part of my work, this Delafield paper, but it does do a really good job at highlighting that we need to be careful about relying too heavily on exclusion zones when designing future energy systems could result in adverse consequences for the cost and the environmental impacts. This is their findings. So they did modelling looking at how strict way you're going to restrict crops. So if you do blanket restrictions based on quality of the land, and when they say about environmental restrictions, it's not talking about not planting on triple SIs or really high value biodiversity land. They were talking about things like national parks and areas of outstanding natural beauty. How you apply those criteria can actually increase the cost and limit the area that you have available and start to push it to where you're putting crops in areas where the yield is lower, so you need more land. So you end up with these observers. We have to be really careful about what that definition is, but that's really their work, not mine, but it's an important point to make. The other thing that's in there is about protecting high carbon soils. I personally, and would fit with our research, would welcome the inclusion of allowing pluriculture. So that's wet agriculture on high carbon soils, not fully excluding the use of those. I would say, though, that we need some care there in how we ensure that doesn't create loopholes for unsustainable use and disincentive for peat and restoration. So in terms of what you might use, we have some work going on in UKCH in the Ag Zero project, Ag Zero Plus project, where we're looking at growing numerous different crops on drained peatland or previously drained peatland with a raised water table. That's the image you can see there, which includes miscanthus and willow as examples, as well as a range of other crops. So pluriculture can work, is then getting that definition right. So that's something I'm going to be feeding into with my colleagues. The other one, which is where my main research is around that evidence we might have around soil carbon. So the consultation is seeking views on which crops should be subject to soil carbon criteria and soil monitoring requirements, and whether that should apply to dedicated and whole crop harvesting. So I'm going to give you some evidence of work we've done on these crops for you to draw your conclusions on what that might be. So in terms of perennial crops, so I've done various bits of work on sampling bioenergy crops across the UK, looking at implications on soil carbon, both under willow and miscanthus and short rotation forestry, experimental plots, short rotation property mainly. On average, so at a mean, we get a neutral or positive effect on soil carbon when they're grown on agricultural soils. However, we do get a variation based on soil type, the initial soil carbon stock, and the land management. So the images you can see down the bottom are from that top paper. And what we've got there is all the SLC, miscanthus, and the SRF from the second paper that we did sampling. Anything above the line is a gain in soil carbon stock under the bioenergy crop compared to a control. And if it's red, it's an arable control. If red is an arable control, green is a grassland control. Anything below the line is where we get a loss under the bioenergy crop. And there is some variability in there, so that might justify monitoring. So I've moved my cursor now. Next slide. The other one to think about is that whole crop harvesting. So we have got examples in UKCH where we have done monitoring on maize crops that have been grown for biomethane on peatland, and that does result in a large soil carbon loss. That should be excluded or might be excluded. But then even on mineral soils, where we've also done work, or my colleagues have done work looking at the implications for that, we still get or can get soil carbon stock loss under maize. But again, it very much depends on the management, the site conditions. So again, there may be an argument there for needing monitoring to ensure best practice. But then there's a load of caveats that I'm going to put on top of that. There are a lot of caveats around soil monitoring that we need to consider. So you'll see this in a lot of the different papers. One of them, which Miriam's all talked about, is the monitoring period. So changes in soil carbon stock, especially under perennial crops, is not linear. So you might get losses initially followed by gains later. So we need to think about what the monitoring period is for these crops in order to ensure we don't end up disincentivizing a land use change, which in the future will be beneficial but might have short-term losses. There's also questions around detection and attribution. This is going to be a huge challenge for annual crops like maize that are grown in rotation with other crops, where you're then going to have to attribute any change in soil carbon potentially to a bioenergy crop that's been grown in a food crop, and that's going to be technically quite difficult. It's also quite technically difficult from soil sampling to detect changes in soil carbon on a yearly basis. We generally don't do that in research. We use alternative measures like eddy covariance, but they're expensive and I wouldn't expect people to be doing that in a commercial setting. The monitoring methods are going to have to be robust. So things we need to consider under energy crops is the potential for redistribution of soil carbon within the profile. So we end up with a concentration of soil carbon in the surface soil and loss in the lower levels. That can lead to, if the sampling isn't deep enough to account for that, you can end up with mistakes on what that is. There's also the cost and the appropriateness of counterfactuals and baselines. So what should we be using for those? The other one is the application of the outline. If we're just looking at soil carbon stocks change needs to be considered in the life cycle. So there is not a direct line between the highest soil carbon stock gain under a crop is necessarily going to equal the lowest greenhouse gas emission per megawatt hour. And if you want to push it the really far way, in this paper we looked at when we looked at biomethane grown on peatlands, although we weren't looking at again, we worked out that you could actually but you could lose up to 9 tons of carbon per hectare per year of CO2 and still end up producing biomethane at a very high level of an LCA that had the same carbon content as your natural gas. So it's not about necessarily that no soil carbon can get lost if you're talking about your overall balance. So that didn't include all the production costs. So it's a very baseline look at what that might look like. So it's again being really careful that we don't get so focused on soil carbon that we forget about the rest of the greenhouse gas emissions and benefits from the crop. Saying that as a soil scientist.
Rebecca,
just brief. Yeah.
Can you take one more minute and then come to an end?
Yeah, the other one just to run on is, this is my last slide, just to say, I'm not going to go into this, but there's a question around emerging crops and sustainability criteria. There is a piece of work that we did the Supergen on novel crops, where we brought together academia, industry and policymakers to talk about what those future crops might be for the UK. So there is a list within that workshop of what those are, and then a selection of them. There's a set of sort of one pages on the description of the crops and what the economic and environmental considerations might be around them that could be useful resource for people. That was my last slide. So you can now quiz me on my not so good high level LCA, Miriam.
I want. Not now. Thank you so much. Thank you so much, Rebecca. So just to remind people, if you have any questions on the presentations, feel free to put them in the Q&A section. We will pick them up later. As we're not having question asked, but just put in the chat. And I'm handing over to our next presenter, Andrew. The floor is yours.
Thank you, everyone. Hopefully you can see my screen and hear me. So I'm Andrew Althorpe. I'm from the University of Manchester Tyndall Centre, and I'm going to talk about mapping biomass sustainability trends and trade-offs. And this basically is the body of work I did with Supergen a number of years back with the last round of Supergen. I start here. As you're all aware, you all work in this field. Bioenergy is very much under the microscopes. It's more necessary than ever to make sure that what we're doing is sustainable, because there's lots of bodies out there who will pull us up if we're not. And as Miriam suggested or highlighted earlier, sustainability focuses very much around land and GHGs. Make sure you don't do anything silly with the land, biodiversity, carbon perspective. Make sure that what you're doing from a bioenergy perspective results in a lower carbon emissions than an equivalent. Sustainability criteria filter down from the international level. The EU level still have a footprint in what we do here in the UK with national policy and the sector level. But those land and GHG emissions are very much where the criteria are founded. This looks complicated here, but what you'll see from this diagram is each of the columns there are some famous sustainability assessment schemes that people use to assess the sustainability of their projects. And each of those there represents a different sustainability issue, everything from contracts to health, to biodiversity, etc. And the patchwork of green and white there basically shows what schemes cover and what they don't cover. And what you'll see, there's no scheme that covers the whole range of sustainability issues. Some schemes are covered very broadly, but depending on what scheme you use to assess the sustainability of your project, chances are you'll assess sustainability of some things and not of others. We did some research. We looked at the main models that the policymakers use, and we looked at how do they look at issues from a sustainability perspective. And as you can imagine, the emissions and land are covered quite broadly, but there are some issues such as water, jobs, etc., they're not covered at all within models. So there is potential blind spot there. We realised on the terms of sustainability of bio from a policy perspective. So that came on to what our task was. We wanted to develop something that would kind of address that. So we made something called the Bioeconomy Sustainability Indicator Model, or the BSIM, developed by myself at Manchester and colleagues at Aston, working with many people on this call from government, academia, NGOs, etc. We wanted a tool that basically assessed the sustainability of bio projects, whether it's just the resource, the feedstock technology, or a whole supply chain. And it's out there. Anyone can use it. You can access it online. There's a manual. There's references there. Please get in touch if you're interested in this tool. And as Dan highlighted before, this is how it is. This is our architecture. It works on the principle that every bio project is essentially the same. It starts with a resource. Steps will take place to harvest, to grow, to collect that resource. That resource will be turned into something, processed in some way, and then there'll be more steps will take place, and that something will then be converted into a product, an energy, or some vector of some sort. And we realized that every kind of bio project is essentially the same, although they're coming at it from all sorts of different angles. And we came up with a long list of sustainability indicators that would try and assess all the issues, all the sustainability issues that would link to across this process. We took those sustainability indicators, many of them, we identified 126, and we developed a sustainability assessment framework, as you can see there. And our framework basically was rearrange these things into a framework that allows you to assess sustainability in resolutions. What I mean by that? So we ranked all these indicators into 4 main categories: those that impact people, development, natural systems, and climate change. Within each category, there were a number of themes. So, for example, within the climate change theme, we had emissions. Within each theme, we had indicators. So, for example, land use change is one of the indicators within the emissions theme. And then we had a long list of the actual issues, for example, direct land use change, indirect land use change, as you can see there. So what we built is a framework of assessing sustainability, try and assess all the issues rather than the patchwork, as you saw earlier. And what our model essentially does, I'm galloping ahead here, I can tell you how it works if you get in touch with me, but essentially we try and map the sustainability of a given project. We develop things such as this, it's like a radar chart, you can see all the spokes of the wheel there, different sustainability issues, and we try and map potential risks and benefits of a given project, and basically show you where the risks are for a project, where the benefits are, where you could focus your resources to address things. I think the real value here is in this dashboard. This kind of follows that framework we have, the different resolutions. You can see here the categories on the left there: people, development, natural systems, and climate change. As you go down the resolutions, the themes and the indicators, you can see we assess sustainability at different levels. And you can see where it's green, we've assessed for this given project that there's a potential benefit, and where it's red, there's a potential risk. So on the high level terms, you look at this project and say, yes, there's a benefit there, green for people, development, natural systems, and climate change. But if you look down the sustainability issues that make up those things, you see there's definitely reds there as well. So essentially, this allows you to look at bioenergy sustainability in a more nuanced way, in a mature way. So, for example, even though this project is sustainable potentially, you can see there are issues here on techno-economics, efficiencies, etc., etc. So there are always things that are red and always things that are green. We've never yet modeled a project that is totally green or totally red, but by doing this, you can identify the risks where you can basically put your energy and resources to try and mitigate, and you can identify the benefits where you can promote and replicate hopefully within your projects. And it allows you to look at these projects in a more nuanced and mature way. For example, if you were to bite the bullet and say, yeah, I know techno-economics are not perfect yet, we're going to invest in that, but I'm going to promote this project because by doing this project, look at the wider jobs I'm generating, look at the impacts I'm generating for water, for biodiversity, etc., etc. So it allows you to assess sustainability at this greater extent. We also assess in our model the SDGs, Sustainable Development Goals. So there's a crazy diagram, but I really like it. So on the left there, you've got all the themes that are covered in our model, everything from health to land, etc., etc. And in the middle column there, you've got the SDGs, 17 SDGs. If you ever done work with the SDGs, there's those 17 are basically just titles. On each of those, there's 10 to 25 different targets. And what we did is we went through all those different targets of the SDGs. We made a link of whether potentially bioenergy could link through to them. And all those crazy lines there are basically a nice way of showing that, yes, a bioenergy project, in theory, could impact every single one of the SDGs. So if you have a sustainable bioenergy project, your project in theory could have a positive impact on all the SDGs, which is obviously a good story to tell. But on the negative side, if you do something bad, in terms of a bioenergy bad practice, in theory, you could be badly impacting each of the SDGs. So, but more so than any other renewable technology, bioenergy basically has an impact across all the SDGs, which is something you don't get for solar, wind, etc., etc. This is how that's communicated in the model. You can map the impacts on the SDGs, and as I said, each of the SDGs is made up of a lot of targets. So there's a potential that you might benefit some of the targets and be detrimental to other ones. But overall, you can map whether your project is an overall benefit or not to the different SDGs. How we made this wonderful model? We worked with all our colleagues across Supergen, 23 different partners, and we kind of basically assessed lots of live projects to map their sustainability, to test our model, and to work out trends and etc. So this basically demonstrates all the projects that we mapped through the Supergen project, all sorts of resources, all sorts of different technologies, different vectors, products, etc., etc. And by doing the assessment of lots and lots of things, we're able to pull out some sustainability trends. So, for example, with the projects that used energy crops, as a map there, some things to pull out. There was a consistent risk, for example, for land, as you may expect. There's also a story to tell about jobs, benefits for jobs. Here we've got forestry residues, carbon stocks. There's a risk, the common risk there, as you may expect. Again, a good story to tell about economics. Wastes, wider sectors, lots of benefits for those, but issues around efficiencies. And finally, for energy crops there, you've got infrastructure benefits and potential issues for soil, as we've introduced. So what we're able to do in assessing lots and lots of projects is to kind of build a theme of what's the story of sustainability across bioenergy. And if you look, we took a step back and looked at bioenergy in the rounds, we found consistently benefits for people. Jobs is something we really need to sell. Bioenergy and biomass sectors produce lots of jobs, good for income, partnerships, energy. It's good for the economy, good for the bioeconomy, good for land and land sectors. Potential benefits of removing heavy metals, water systems, flood prevention, soil, climate change, obviously emissions and replacing fossil fuels, etc. These are all the benefits of bioenergy projects that we kind of identified again and again, things that we need to use to sell our projects and promote them. But again, on the other side, on the flip side, we've got all these risks here, constant risks around land management, efficiencies, techno-economics, infrastructure, all big ones. Those are where the energy and resources of the theory need to go. There are issues with the air pollutants and water use with certain technologies. And at the bottom then there, the flip side, climate and emissions. If we don't do it sustainably, if we do bad practice, then things can go horribly wrong from emissions and carbon perspective. But I hope that's where legislation comes in to fill that space. So I know I've really run through our work here with some final sustainability thoughts. Sustainability is like a really tough term for bioenergy because bioenergy itself is a really broad thing, all sorts of resources, technologies, and sustainability is a broad thing. So when you talk about sustainable bioenergy, it's far from a homogeneous concept. So when you have a policymaker having to kind of regulate that, so I said that's a hard task in itself. And our research really shows that sustainability is this series of trade-offs rather than a green destination. It's not a tick. Every project will have risks. Every project will have benefits. It's about making choices about what flavor of sustainability, I guess, you would like to have. Current legislation really focuses on that carbon and biodiversity angle, but as our research shows, sustainability goes far beyond that. Jobs, water, etc., etc. And there are no current mechanisms to ensure that potential benefits are achieved and maximized. All the mechanisms are focused on, ensuring that the minimum standards are achieved and bad things don't happen. There's all sorts of benefits that we should be shouting about. Surely there should be some policy mechanisms, something that ensure that those are realized. And a theory we had in one of our papers, would an approach of awarding credits across the broader range of indicators, as well as minimum standards, would that be a better system, for example, of assessing sustainability of a given project? Please get in touch with us if you want any more information on the model, how to use it. Some of the key references are there on the right, characterizing that. And as I said, it's a free to use model. Download it and get in touch. Thank you.
Okay, thank you so much, Andrew. And just to remind people, the link to the model is directly also in the slides we will share later in the earlier presentation we shared between Dan and me. So we have one more presentation to go before we go to our Q&A session, and I'm very pleased to invite Paramala to present on her work with now a focus on non-energy products.
Thank you, Miriam.
Okay.
Just checking you can hear me and see the slides.
Yeah, we can hear you, and slides
Perfect.
are coming up. Yeah, slides are there. Perfect.
Perfect. Thank you.
Thank you.
Very good afternoon, everybody. And I'm a bit of the outlier here. So we heard a lot about energy and land use. It's so a little more downstream in terms of what can we do with some biomass. So I'm one of the co-Is at Supergen, and I'm leading more towards the biochemical strand within the hub. And my research looks at how we can use waste flowers or horticulture waste in the UK to produce bio-waste chemicals. So in terms of the chemical industry, this is no new news. We are one of the biggest emitters of carbon dioxide, and there's an increasing need to defossilize processes and products from this industry. And when we look at two main challenges, it's usually what they say is the lack of raw materials towards alternative feedstock. And what's really close to my heart is the high cost of manufacturing some of these alternative bio-based products. If we look at this cartoon, I used this in my PhD thesis. I love this cartoon. This is how we traditionally scale things up in the chemical industry. And if we want to move towards alternative feedstock, the question is, do we still scale up in the same way, or do we look at, do we evolve the scale up technologies along with our alternative feedstock, and if this is the best model to go forward? And in terms of the opportunity in this sector, just taking the example of fragrance ingredients, because that's one of our target outputs, is that it's one of the largest imported products within the UK. And there is a very strong shift towards making manufacturing more domestic and bringing back manufacturing and looking at different ways of manufacturing in the UK, and especially in the areas of recycling, reuse. But what's really closer to my heart, although it says 2050, I think we should be thinking about this right now, is the whole idea of decentralized model, or where we can actually have factories close to where the biomass is actually obtained, so that we can be more resilient in the way we produce some of these products as well. And in terms of the biomass availability, especially horticulture waste, you might ask, is there any within the UK? So Bridge Farm are one of my key collaborators. They're not very far from where I live in Nottingham in Lincolnshire, which is actually a horticulture belt in the UK, produce a large surplus of cut plants and ornamental flowers for the UK supermarket, and end up generating quite a lot of waste every season, which is a potential raw material for some of the products I'm interested in. And just some numbers based on some of the early LCAs and the TEAs we did even just processing 10% of this waste has a big impact in terms of the economic growth, but also the emissions reduced. And we'll speak a little bit more about this in my LCA slide a little later. So what we're doing as a group at Nottingham is that we are developing a flower waste biorefinery, which means we take the waste flowers or the plants or the whole plants coming from the farms, and then we're looking at 3 different strands. We are looking at can we extract some high value chemicals from these flowers, and we're doing a series of structural modification to come up with some drop-in replacements within the chemical industry, be it in fragrances, flavors, and polymers. And then we're looking at how we can scale this up so that we can meet the demands of the chemical industry. And once we have extracted what we want from the from the flowers of the plants, we're left with the spent biomass, which we then subjecting to microbial fermentation, and then still looking at if we can make some interesting bioactive compounds. And as a whole biorefinery approach, of course, we are also assessing the LCA and the TEA of the system. So I'll just take you through a few results from this work so far. So we use what's called the ultrasound extraction method because it's fast. It also preserves the quality of the oils compared to more traditional steam distillation techniques. And this is just one part of the study which we've done. We've screened several flowers. This was just for marigold, and we looked at what's the key fragrance and the flavor properties of some of these flowers, and we did this across a few different flowers originating from the farm every season, which was quite interesting in terms of their odor properties. And once we've extracted these oils, we want to see if we can make them into fragrance esters as one of our key targets. We're trying to do this work on the crude flower oils. This is still early days, but this was what we did with some commercial rose geranium oil. So we saw if we could use some lipases and the enzymes and make them into esters, and then do some continuous production to scale this process up. But more importantly, we looked at from a very sort of chemistry and engineering perspective, we also developed a model so that we can control how much of these products we're making, and so that, especially in a very heterogeneous feedstock like flowers, it's really important to understand how this pathways work. And we were very successful in making some, for example, geraniol and citronellol esters, which are key fragrance ingredients from this rose geranium oil, and within 5 hours. And we got better results with the solvent-free systems which we've developed, and we're now looking at how to scale this up in sort of modular reactors. And in terms of, does this actually have value of actually using flowers? So this was a study which we did last year we collected a series of waste flowers from Bridge Farm and did just the extraction. This was not based on not on the esters, but even just the oils, which we got out. So just to show that we can actually use non-purpose grown horticulture crops originating in the UK as potential source of fragrance ingredients, and we don't really need to export or grow fields of roses and jasmines, but then there's some real potential in the feedstock available in the UK. And some, again, early LCAs, and just leading to what Rebecca said about how much carbon we produce. So if we were to grow roses just for the purpose of extracting some oils from them, just the cultivation alone has the maximum amount of carbon dioxide footprint. So if we are actually growing surplus horticulture crop, might as well use it for something more useful. And we also did some LCAs on the production, which is the extraction of the oil, which so the production, the flower production, oil production was from literature, and the refinery process was what we did in the lab in terms of converting into esters and so on. So the actual refining process and taking the oil and making it esters is actually quite low carbon footprint. So it's quite nice to see that we're sort of going in the right direction. But I think the key thing is, do we actually need to grow purpose-grown crops, or can we look at what's already surplus available and do some interesting chemistry on that? And some quick results on, so, like I said, after we've taken this extracted from the flowers, we have the spent microbes, and we've got one of the PhD students who's looking at making some bioactive compounds, and there's a QR code there as well for the publications if you're interested. And some very recent work, from a research fellow and another PhD student is we're looking at if we can use some of these oils and esters as a precursor to make bio-based polymers. So be it in home and personal care formulations, or the last one is really close to my heart. It's with the medical school at Nottingham. We see if we can make some biofilm resistant films for incubator panels in the neonatal care unit. So in terms of what we're doing next within the project, like I said, crude oils are really hard to deal with. So we're looking at how we can optimize that system to make these drop-in chemicals, and also interested in decentralized processing models, and also just adapting our LCAs and TAs more so that we can demonstrate to the industry there's a real potential in using this feedstock. So just want to thank the Flower Power Research Group and all the collaborators and funders, and thank you for your attention.
Thank you so much, Paramala, and thank you also to the Flower Power Group. That's a fantastic name for a research group. I'm getting a bit jealous there. that's great. So we now have seen all the science presentations for our webinar, and I want to say a big thank you to all the presenters for that. We have a few minutes left for questions.